NASA has a sort of expression is, follow the water. And my research is in the early Mars atmosphere. So we're trying to find places that have liquid water, and those would be good starting points to look for life. The big mystery is, the geology suggests there was liquid water, but the atmospheric greenhouse gas modeling says you couldn't support that. And so I was trying to understand that mystery. One idea to try and solve this mystery is perhaps the atmosphere doesn't need to be thick enough if the atmosphere's composition is capable of absorbing and trapping enough heat itself. And one way an atmosphere can do this is what's known as collision-induced absorption, where two separate molecules collide together and they form a supermolecule that is two other molecules, and that supermolecule itself has its own absorption profile and would contribute to the overall absorption of an atmosphere. So the collision-induced absorption is a weak effect. It's not that strong. And so you really need a sensitive instrument to detect it. And that's what the c.l.s. has. We were trying to make experimental measurements of this absorption profile and see if that could provide enough warming. And there was a paper that suggested that carbon dioxide, which is plentiful on Mars, and either methane or carbon dioxide and hydrogen gas, those collision-induced absorptions may be able to provide enough warming. And then we made these measurements and found it was actually a little bit weaker than they predicted. So this was a bit of a double-edged sword here. It's weak enough that for methane, that does not provide enough warming. So CO2 and methane is not strong enough. But CO2 and hydrogen, even though it was a little weaker than they initially predicted, we showed that it is still strong enough that you could get some warming, sufficient warming with that. It's all about where in the electromagnetic spectrum does it absorb. Even though it isn't that strong of an effect in itself, because it's absorbing in a part of the spectrum where nothing else is already absorbing, it can provide a significant impact.